Hey guys, welcome to my video on likelihood ratios versus predictive values, and I'm going to start out by encouraging you to please subscribe and turn notifications on. So predictive values and likelihood ratios are both ways that we interpret diagnostic tests. So that is why careful reading of diagnostic interpretation questions is very important. A likelihood ratio is, so when we're given a certain test result, the likelihood ratio answers the following questions. 1. What is the likelihood of the patient having the disease versus not having the disease? 2. How more likely is it that he or she will have the disease? 3. How more likely than not is the patient to have the disease? So these three questions are kind of asking the same thing. They're just worded a little differently. One important point about likelihood ratios is that likelihood ratios tell us about the influence of the test in question. And I'm going to talk a little bit more about that towards the end of the video. But another very important point about likelihood ratios is that they are independent of prevalence. And please note that when we talk about a positive likelihood ratio and a negative likelihood ratio, the positive and the negative, the signs are referring to the test result. But you are always dealing with a ratio of diseased versus non-diseased in likelihood ratios. So if you're dealing with a positive likelihood ratio, it's a ratio of diseased positive versus non-diseased positive. In contrast to likelihood ratios, predictive values are probabilities. And another thing about predictive values is that they're related to the prevalence of the disease in the population. So I have two videos on PPV, NPV, and prevalence and the trends, the calculations. So I have the links in the About section below. To show you the difference between when you apply a predictive value and when you apply a likelihood ratio, I've written two different vignettes. So the first is a novel new test for lung disease with specificity of 0.81 and sensitivity of 0.75 is administered in a population with lung disease prevalence of 0.31. A patient tests positive. What is the probability that she actually has a disease? The second vignette is a woman undergoes screening for lung disease with a test that has a specificity of 0.89 and a sensitivity of 0.82. The prevalence of lung disease in her community is 0.5. She tests positive. How much more likely than not is it that she has a disease? So first of all, in the first question, it's telling you that she tests positive and asking you the probability that she actually has a disease. So it's asking you for a predictive value, and it's a positive predictive value because notice she tests positive and they're asking you if she actually has a disease. So in this case, you would need the three numbers that are provided, the three values that are provided, the specificity, sensitivity, and prevalence. As for the second vignette, notice that it asks you how much more likely than not is it that she has the disease. And so we're looking at a likelihood ratio. What kind of likelihood ratio? We're looking at a positive likelihood ratio because it says she tests positive. Now, another thing I want to point out is that the information about prevalence is not needed in this calculation for our likelihood ratio because, as I said, likelihood ratios are independent of prevalence. So in terms of calculations, likelihood ratios for both positive likelihood ratio and negative likelihood ratio, sensitivity is in the numerator. So sensitivity sits on top of likelihood ratios. Positive likelihood ratios, so sensitivity by itself is in the numerator over 1 minus specificity. So say somebody tells you that a test has a positive likelihood ratio of 11. So how would you explain or interpret that? So that is basically this. If someone tests positive, he is 11 times more likely to have the disease than not have the disease. As for negative likelihood ratios, it's 1 minus the sensitivity over specificity. So the way I remember that in this case you have 1 minus sensitivity in the numerator is that it's a negative likelihood ratio. So there's going to be a negative in front of the sensitivity, and it's not by itself. As for interpreting what a certain negative likelihood ratio is, so say a test has a negative likelihood ratio of 2, the way that you would explain or interpret that is that if someone has a negative test, he is twice as more likely to have the disease than not have the disease. And in a nutshell, likelihood ratios, so as a number, likelihood ratios tell us something about the influence of the test. So an influential diagnostic test would be one where there is a prominent positive likelihood ratio. And that means I'm talking over 10. So what that means is that a positive test, if someone has a positive test result, they're at least, or they're more than 10 times, not at least, they're more than 10 times likely to have the disease than not have the disease. The more nil the negative likelihood ratio, and I'm talking below 0.1. So what that means is if someone has a negative test, they are less than 0.1 times likely to have the disease than not have the disease. And that makes the test influential. And when we talk about influence, and I'm going to show you that likelihood ratios can be used to get post-test odds. So you use it in a calculation to calculate post-test odds. And the higher the positive likelihood ratio, or the lower the negative likelihood ratio, the more influence each one has on its respective calculation. So I want to thank you for watching my video, and I just want to encourage you to subscribe if you haven't, and thank you so much for your viewership.